Welcome to video number 5 of the series of logarithms. In this video, we want to continue the process or the learning of logarithms as we started earlier. And for video number 1, 2, 3, and 4, we're looking at 3 keys that we can use in solving logarithms. And here, I want to solve a series of questions to apply those keys we've learned earlier. So let's take the first example. Now for example number 1, we have to evaluate log base 5 125 plus log base 5 25. You can pause the video and try it, maybe using what you've learned so far. In solving this question, we have different ways you can use. Now one of the ways I will try to solve this question is to change the 125 to indices as 5 exponent 3, and then log base 525 can also be written as log base 5 exponent 2. Then from one of the laws that we studied, exponent here can move to multiply, so we have 3 log base 5 plus 2 log base 5. And then we also learned from our property that log of a number of the same base will give you 1. And so here we can say 3 times 1 plus here to say 2 times 1. And 3 times 1 is 3, 2 times 1 is 2. When we add, we have 5. And that is the answer. That is one way you can solve this question. Alternatively, let's see. You can apply the first law straight away by saying that since this and this are of the same base, you multiply the logs and have 125 times 25. Now from here, indices tells you that this can be written as 5 exponent 3 times 5 exponent 2. And since our bases are the same, we add exponents. And then we also learned that a log can, one of the laws tells us if I have an exponent here, I can move that one to multiply. So I have 5 log base 5. Then since this is 1, the answer now becomes 5. Somebody can also choose to multiply these two numbers straight away, which will give us 3125, and then change this one to an indices of 5 to exponent 5, and so write it and get the same answer. Now let's see example number 2. You can pause the video and try it. Now this question looks a bit complicated, but it's not difficult. You just go by your principles that I've taught you earlier, that is the keys, either the definition, the laws, or the properties. Now there's one trick about some of these questions. Anytime the question comes with a number that multiplies the log, sometimes it will be easy if you move the number to be an exponent, and when it is also in an exponent form, then you can move it backwards to be a multiplier, to multiply the whole log. Sometimes when they give you the question, they want to see how you can apply the laws of logarithm, properties of logarithm, or definitions of logarithm. So let's see how this question can be solved. So with this, I can first choose to write everything here as log base 10 5 exponent 2, log base 10 16 exponent half, log base 10 2 exponent 4. I can write this as log base 10 5 exponent 2 is 25, log base 10 16 exponent half, we know from indices and from sets as 16 exponent half is the same as square root of 16, and that will give you 4, plus log base 10 2 to the power 4 is 16. Then we can now apply our law. Since these two logs are subtracting and the bases are the same, I can write log base 10 25 divided by 4, then plus the remaining logs here, log base 10 16. We can further use the law again. Since we are adding and then the bases are the same, we can write log base 10, maintain the base, and multiply the logs. 25 on 4 times 16. And when I simplify this work here, I could write log base 10. Now 4 can divide itself 1 and divide here 4, and 25 times 4 will be 100. And this can be written as log base 10. 100 can be 10 to an exponent of 2. And so here finally we can say these two could multiply because an exponent, and it will be 2 log base 10 10. And since log base 10 10 is 1, 1 times 2 is 2, our answer becomes 2. Now let's move on to example number 3. Once again, you can pause the video, try it, and resume. I believe you had 1 as your final answer. That is what you had. Well done. If not, let's see how we can solve this question as well. So here we can start by saying that since this one is multiplying, let's make it an exponent. And we have log base 10 25 on 4 exponent half log base 10 4 on 5 exponent 2, and these two numbers we can divide them by 5, and that will give us 64 on 25. So we can further go down and say the exponent here from indices lesson affect 25 and affect 4, and a number to an exponent of half simply means square root of that number. And so I can write square root of 25 is 5 and square root of 4 is 2, minus, then I can say log base 10, the half affects 4 at the same time 5, so it will give us 16, and here I have 25, then plus log base 10 64 on 25. Now using the law of logarithms, since the bases are the same and we are doing subtraction here, we can write this as log base 10 5 on 2 divided by 16 on 25 plus log base 10 64 on 25. Again, this base 10 here is of the same base 10 and we are doing addition here, and so we can multiply the logs, but then this also can be changed to multiplication, so we can write together as 5 on 2 times, then reciprocate this 25 on 16, then because we are adding we also say times 64 on 25, and from here we can do simple cancellation. 16 can divide itself as 1 here and divide here as 4, and so, and 25 can also divide itself and divide here as well. Now 2 can divide itself 1 and divide here 2 as 2. Then finally we have 2 times 5, which is 10. So you have log base 10, 10. And from our previous lesson, log base 10, 10 simply means 1. So the final answer gave us 1. Now with this, we come to the end of video number 5 of the series of logarithm. Our next video will solve more questions in understanding the concept of logarithm. Thanks for watching.